Okay, so last time we started talking about some limits involving infinity, right? So let's just kind of recap some of the important stuff we saw last time. So like, for example, if I have something like this, what is that limit? So like at top, you have some constant, let's say it's positive, and the bottom's going to 0. In this case, what would that be? This would be positive infinity, right? Okay. And then if I have, let's say, the limit as x goes to 0 from the left, this is going to be negative infinity, right? So this is a situation, you have a constant on top, the bottom's going to 0, then you just want to look at the signs to figure out, is it going to positive infinity or negative infinity, right? Okay, now, what if you have the limit as x goes to infinity, let's say, of this, and actually this can be, this at this point can be any constant. What would that be? So now you have some constant on top, and then the bottom is getting really, really, really big.
0.
Yeah, so that's going to 0, right? And then what about the limit as x goes to minus infinity of, say, something like that? This would be 0, right? So it doesn't really matter if it's positive or negative. If the denominator is getting really big, because there's no positive 0, negative 0, that doesn't really make sense, right? Okay. And then another one that we kind of talked about that was important. Let's say you have e to the x, and then compared to something like that, let's say. So what's going on there? What's the limit as x goes to infinity of e to the x?
Infinity. Positive.
That would be infinity, right? So you have e, which is some number, right? 2.7-ish, let's say. And you're raising it to bigger and bigger numbers, so that's going to get bigger and bigger and bigger, right? So this is equal to infinity. But then, oh, here I did the, that's not what I meant. Let's see. Well, why don't we do that? So I took off the negative from this infinity. So if I have the limit as x goes to infinity now of e to the minus x, so now the exponent is negative. So what does that do to?
0.
That's going to be 0, right? And remember, we kind of talked about this a little bit last time. This is like having the limit as x goes to infinity of 1 over e to the x. So now it's some constant on top, and then the bottom is getting really big, so then the whole thing is going to 0, right? Okay, so all that makes sense, right? Any questions about that, or is that all pretty clear? Okay. All right, so those are kind of the fundamentals there. Okay, so now let's talk about, let's take a look at the idea of horizontal asymptotes and end behavior, because we use limits to infinity, and behavior of a function. Okay, so so f has a horizontal asymptote. If either the limit as x goes to infinity of f of x is equal to, let's say, some constant c, or the limit as x goes to minus infinity of f of x equals to c. And here c is, well, I'll just write it down, where c is some constant. Okay, so what are some function types that you've seen in your math career up to this point that have had horizontal asymptotes? What's the most common? Yeah, rational functions, right? So let's take a look at that, because that's kind of the simplest scenario here. So rational functions, typically they'll have one asymptote, right? And so let's say, for example, just to make up something here, so let's say you have 2x squared minus 3x plus 7 divided by 5x squared plus 3x minus 2, let's say. And let's say you want to find the horizontal asymptotes. Okay. So if it's just a straight up rational function, how many horizontal asymptotes do we expect to have? One, right? One or sometimes none, right? When you took pre-calculus, you had sort of a kind of technique, or kind of a shortcut to find the horizontal asymptotes. You look at the degrees. Do you guys remember that? Where you would say, oh, well, here, for example, the degree is 2, and down here the degree is 2. What would that mean if the degrees are the same?
2 and 5 is
Yeah, you take the leading coefficients, right? So this rational function would have a horizontal asymptote of 2/5, right? But you didn't really know why it had a horizontal asymptote of 2/5. You just kind of like memorized the rule and you moved on with your life, and then that was it, right? But really what it is, I mean, what you need to do is actually just this. Find the limit as x goes to infinity, and then find the limit as x goes to negative infinity. So I'm going to show you the technique to evaluate these, which is a little bit different than what we've done so far. I'm not sure what happened there, but okay. So what you do, so here's our strategy. So I'll write down the strategy and then I'll move it to the other page. Okay, so what you do is you divide the numerator and the denominator by x raised to the highest power. And here you have a couple options, but it's typically easier to divide by x raised to the highest power in the denominator. So look at the highest power in the denominator and divide by that. It won't make that much of a difference with these, but when we throw in radicals and things start getting a little bit weirder, then you kind of want to stick to the denominator. Okay. So, well, I'll just write it down here. Okay. And simplify. Then evaluate the limit. And so you can use the same exact technique when you have radicals. So you have a rational function with radicals in it and weird stuff like that, which you haven't seen. And you can do the same thing. So let's go. Let's see here. Oh, sorry. Let's see. So let's do this. So we have the limit as x goes to infinity. And what was it? 2x squared minus 3x plus 7. And 5x squared plus 3x minus 2. 5x squared plus 3x minus 2. Okay, so then what do we say the first step is in our strategy? Okay, so what you do typically is you do this. Let me write it down again. And I'm going to leave a little space down there. And I should have left the space to begin with, but oh well. Okay, so we're going to divide by, what's the highest power in the denominator? 2, right? So x squared. So divide everything by x squared. Okay. All right. And then now we simplify. So what is that going to equal to? This is equal to the limit as x goes to infinity of, so this first one is 2, right? What's the second term? minus 3 over x. What about the third one?
7 over 6.
Okay. And then on the bottom, we have 5. Yep. Plus 3 over x minus 2 over x squared. Okay, and then this is where we use what we talked about in the very, very beginning. So here, for example, if I take a look at this term right here, 3 over x, what's the limit as x goes to infinity of 3 over x? 0, right? Because you have 3, some constant, the bottom's getting really big. So that's going towards 0. What about 7 over x squared?
0.
Also 0, right? So notice all of these that are constants over x, these are all going towards 0, right? And so notice, what are you left with? 2/5, which is exactly what we expected to end up with, right? Does that make sense, the strategy? Okay, so any questions with the overall strategy? Okay, now, what if, okay, so now let's kind of go back here. Let's say, hypothetically, I were to change this to minus infinity. So let's say I change all these to minus infinity, minus infinity. Is that going to change anything throughout? No, right? Because here, so you're dividing by x squared. That's fine. Here, though, if x is going to minus infinity in these, is that not going to go to 0 all of a sudden? No, right? It's the same thing. Because you have some constant divided by x, even though x is now a negative number, it's still going to go to 0. It's not like, so this is different from, so if we go back here a couple pages. So what we're looking at is basically these, right? They're both going towards 0, which is different from what happens with the exponential functions, right? Okay. All right, so that's fine. So now let's do, an example with radicals, because it gets a little bit more complicated here. So let's say we have the limit as x goes to infinity of, let's just say 2x minus 4 divided by the square root of, I don't know, 5x squared plus 2x minus 3, let's say. Something like that. So we'll find the limit as x goes to positive infinity, and then we'll find the one as x goes to negative infinity after. Okay, so what would be our, if we kind of follow the same strategy, what would we do? Divide by highest power in the denominator. Okay, what is that? Yeah, so you have to be careful, right? So notice there's an x squared there, but you're getting the square root of it. So actually the highest power is 1, right? Okay, but you have to be careful because you're dividing by x. You cannot just bring in the x inside of the square root, right? Why? Because, well, so here, let me, maybe over here on the side. Let's see. If I have square root of, let's see. What do we do? Let's do numbers. Square root of 8 divided by square root of 2. What is that? This is square root of 8 divided by 2, right? Which is then the square root of 4, which is 2, right? But if I have that, is it okay to say, oh, well, that's the same as 8 divided by 2?
No.
Well, no, right? This does not make any sense whatsoever. So I'm either, so here in the limit I'm dividing by x, but that's not the same as dividing by square root of x, right? Okay, so we need to do a little bit more to get that square root in there. So it's not that we can't, it's just that we have to do some more stuff. Okay. All right. Now, so let's think this through a little bit. So to bring it inside of the radical, it needs to be written in a different way, right? So this x has to be written so that it has a square root under it. So what would it be?
Square root of
X squared, right?
Oh, yeah.
Okay. All right. Okay. But there's a bit of a problem because are these equal to each other? Is x always equal to square root of x squared? It's not equal to. So like for example, if I plug in, just if you think this through a little bit, let's say you plug in 2 here and 2 here. Do you get the same number on the left side and the right side?
Yeah.
You do, right? What if I plug in 12? What if I put in negative 12? I've got a problem, right? What happens is this, okay, so here's the problem. The problem is that, let's see, this right here is actually the absolute value of x. You guys agree with that? Because the right side is always going to be positive no matter what, right? Okay, so what you need to do is you need to be a little bit careful. Because remember that we've done this before, right? The absolute value of x is equal to, and remember I told you guys we were going to do this over and over again? So how do I write the absolute value of x as a piecewise function?
X is x greater than 0.
Okay. When x is greater than 0, it's just equal to x, right? When x is less than 0, absolute value of x is equal to negative x, right? Okay. All right. So, so that's just kind of a long-winded explanation to say that you have to be a little bit careful because, so in this case, x is going to positive infinity, which means x is going to be positive, right? So in that case, it is okay to swap out absolute value of x with x, right? Why? Because x is positive. If x was negative, then what would I have to do? Negative x, right? So do you guys see where we're going moving forward? After we do this problem, then what's going to happen in the next problem we do? Well, x is going to go to negative infinity, and what are we going to have to do? We're going to have to switch it out for negative x, right? So it's just a matter of just being a little bit careful. Okay, so any questions so far? So I know that was kind of a lot of extra information there, but it's important to make the distinction. So here, where I have the square root of x, or sorry, where I have x, I'm going to change it to the square root of x squared. And again, I can do that because the absolute value of x is equal to x when x is positive, right?
We have to do that for the part in the numerator also? Change
No.
x's?
Because in the numerator, there is no square root. So there's no need to change it to square root of x squared up there. Does that make sense? A little bit. Okay, so now what does that allow me to do? So now if I take a look here at the next step here. So let's simplify. So here on top, I'm going to get 2 minus 4 over x, right? Okay, now on the bottom, because they both have square roots here, now I can put them together and divide everything by x squared inside. Like that. Does that make sense? So I'm bringing in the x squared, I'm combining the two radicals, and now I can simplify, right? So here if I simplify the x squareds, x with 1x, and now can I evaluate the limit with what's left over? I've simplified, right? So if I evaluate the limit as x goes to infinity, what happens to this guy? This goes to 0. Okay. What about here? What's That's the number 5, right? Because x squared over x squared, that equals to 1. So then I have a 2 over square root of this 5. And then what about this 2 over x?
Goes to 0.
That goes to 0. And what about 3 over x squared?
Goes to 0.
That also goes to 0.
So when you say if x was negative, you mean if x was going to negative infinity?
Yes.
Then let's say it was negative infinity. Would we put the negative outside of the square root?
Yes.
Or inside?
That's the next thing we're doing. Yes. So that's a different problem, but so let me does anybody have any questions with this one? Does that make sense? 2 over root 5 and then we're good to go? Yeah? Okay, now we don't have to write down absolutely everything again, but let's say we have the limit as x goes to minus infinity of, what was it, 2x minus 4 square root of 5x squared plus 2x minus 3. Let's see. Okay, and then let's say we kind of do the same thing. Divide by x, divide by x, divide by x, right? Okay, so what do I need to do? I need to turn the x into square root of x squared, right? So that I can combine the radicals. Okay, so make sure that this makes sense here. So let me go right here. All right. Notice right here, x is going to negative infinity. That means x is negative. Do you guys agree with that? Or in other words, x is less than 0. Yes or no? Okay, so x is going to negative infinity, x is less than 0. Okay, what I'm trying to do is I'm trying to get this that I have right here. I want to say that that's equal to the square root of x squared, or the absolute value of x, right? Those two things are the same thing. Yes? Okay. Can I say that in its current state? No. Because if x is negative, if x is less than 0, then what is the absolute value of x? Negative x, right? So what do? Well, it's not that bad. What would you do here? If I want this x to be a negative x, what do? Put a negative in front of it, right? Okay, but what else do I have to do? Negative on the radical as well, right? So it's like, basically, it's like multiplying top and bottom by -1, essentially, right? It's like if you were going to combine two fractions and one's positive, the other one's negative, so you multiply top and bottom by -1. It's basically the same thing. But now, since x is less than 0, this minus x is equal to absolute value of x, or the square root of x squared, which is what you want, right? You want to change that to the square root of x squared so you can simplify. So we won't go through all the steps again, but basically what's different from this one compared to the last one? There's an extra negative, right? There's this negative sign, this orange one that's right here, that I now colored green, wasn't here, but everything else is going to be the same, right? You're going to have divided by square root of x squared. Everything is going to simplify the same. But in the end, you'll end up with 2 over negative square root of 5, right? Does that make sense? So what does that mean about this function? If going to positive infinity, it's one number, to negative infinity, it's another number, what does that mean? What do the limits to positive and negative infinity tell you? The asymptotes, right? What does that mean?
Limit doesn't exist.
Nope. There is an asymptote. Tells you more. There are 2 asymptotes, exactly, right? There's 2 horizontal asymptotes, because when you go to positive, when x goes to positive infinity, you get one number. When x goes to negative infinity, you get a different number. What are you going to ask them?
should there be another negative sign in the numerator? So should the 2x minus 4 be divided by negative x? Because wouldn't you just get a positive number in the numerator, making it positive 2 over radical 5?
No, I mean, it depends on the way you approach it. So in this case, we said, okay, we're going to divide by x. And then we changed this x to a minus x by just multiplying top and bottom by minus 1. If you felt like it, if you wanted to take an alternative approach, let's say, okay, this is alternative. Are you guys ready for alternative? You end up with the same thing. But let's say you say, oh, I'm going to divide by minus x from the get-go. Everything. Like that. So now what happens? Well, this time, what is minus x equal to? Since x is negative, since x is less than 0, negative x already is equal to the absolute value of x, right? Okay, so that's a substitution right away that you can make. And then what ends up happening is you end up with a minus 2 over positive square root of 5, which is the same thing. So it's just the approach, but that's probably a more unconventional approach, just because you wouldn't think to do that ahead of time. It's more you would realize you needed to make a change once you get there. So it's just a matter of being a little bit careful. You know, sometimes what happens is, you know, you're like, you know, you're doing something like this, and it's like, oh, whoa, wait, undo. Okay, you're doing something like this problem, and you're like, oh, well, it's always just the top divided by the bottom, and then you're done, right? And oh, this one's the same thing. So you kind of get into this sort of routine of, oh yeah, you always do this, and then it always comes out to be whatever, right? And then, but you just have to be a little bit careful, because sometimes, like in here, you know, when you have radicals, well, if it goes to positive infinity, it's one number. If it goes to negative infinity, it's another one. Well, why is that? You know, a lot of calculus is like that, where, you know, previous classes, it's like, oh, well, who knows why things happen, but, you know, you memorize these steps, and all of a sudden, magically, you know. But calculus, you know, a lot of it is really understanding why things work the way they do. You know, it's kind of like taking that extra step. Going deeper in understanding. Any other questions with that one? No? You good? You guys want to try one? You guys want to take a break, or you guys want to try? Try. All right. That's the spirit. That's the spirit. Let me see if I can find a good one for you guys. How about... Okay. How about this one? I'll give you a hint to start it off. 9x squared plus x, and then minus 3x. So, well, notice that there's no fraction to divide top and bottom by x raised to the highest power. But you can, how would I make that into a fraction? What can you do? Multiply by, yeah, the conjugate, right?
Conjugate.
Top and bottom. Okay, so give that a go. And multiply by the conjugate is the first step. So if you do... All right, so that's the conjugate, right? So you multiply by the conjugate to turn it into a fraction. And you end up with the limit as x goes to infinity of So be a little bit careful with what is under the radical and what is not. So the 3x is not under the radical, right? Okay, so now when you distribute the top, that's a difference of squares, right? So then what happens to the radical here in the very beginning, this first one? That's 9x squared plus x, right? Okay? Minus 9x squared, right? And notice that these two cancel out. So what's the highest power? Yeah, just x to the 1, right? So then, but then here you have to be careful again, right? So you divide this by x, divide this by x, and this by x. Right? No?
Divided by x squared.
Squared, the root,
Underneath
the root 9x.
Oh, well, you guys are a step ahead of me. But,
But yeah, so far you're, yeah, that's, yeah.
okay, so what is that equal to? That's equal to...
1/6.
Okay, so this is 1 over... So right here, this guy is going to be the square root of x squared, right? Okay, so then what do I end up with? Bless you. This is going to be the square root of... So the x squared cancels out with the x squared, right? So this is going to be 9 plus x over x squared reduces to 1 over x, right? Which then goes to 0, right? Okay. And then here the x over the x, that's just 3. But be a little bit careful because the 3 is not under the radical, right? So the 9 is under the radical, but the 3 is outside of the radical. So then what do you end up with? 1 over 6. Does that make sense? I see funny looks. You're like, not so sure. Okay, so ask me questions. What do you guys think? What part? Ask me something. Okay, there we go.
When you divide the x squared on the square root of 9x plus x, where does the other x go?
Okay, so I did go through that pretty quick there. So this is square root of x squared, right? Which is then the square root of 9x squared over x squared plus x over x squared, like that, right? Which then equals to the square root of 9 plus 1 over x. Right? Here, this one cancels with one of those. Okay, and then what happens to... So then you take the limit, right? So as x goes to infinity, 1 over x goes to 0. And so that's where it went. So that's where the square root of 9 comes from. Any other questions with that?
Is that how you want to strike that on the test? Like the arrow up to 0?
Yeah, that's a
You
good...
cross that out.
I mean, I like to put the arrow with the 0, so it's like it's going to 0. But I mean, there's some leeway. As long as it's not weird, you know. What would be weird? If you did... Smiley faces would be a little weird, but I probably would not take off any points for smiley faces. Did anybody do it with x going to negative infinity? What did you guys get?
Negative 1 over 6.
0?
Does not exist. What else?
Negative 1 over 6.
Negative 1 over 6. What else? Anybody else? Do it? Well, because it's not either of those. it's neither of those two. What? What? Okay, so let's do this. All right, so let's change. Let's do the limit as x goes to minus infinity. Okay, so I'm going to change that right there. Okay, so we actually already broke a rule. We broke a rule already. What was our rule? That we haven't done today, but we've always been doing this whole time. Evaluating limits. What do we always do?
Always plug it in.
Always plug it in first. Now, infinity is a little bit weird because, I mean, you can kind of plug it in, but it's not a number, so it's kind of a little bit strange. But let's just kind of go back here a little bit and just to make sure. If you plug in, you can't see that I did plug in quotes, so I'll write it down. Okay, plug in, plug in infinity in quotes. What do you get on top? You get, it's basically going to infinity over infinity, right? Okay. That was one of our indeterminate forms, right? Okay. Now, if you go back to, let's see, the next one, what do you get when you plug in infinity? Infinity over infinity, right? Square root of infinity, which is still infinity. So meaning it's going towards infinity top and bottom, right? Which is indeterminate. Okay. Which means more work, and that's why we've been doing more work, right? Okay. Here, if I look at the first problem here, this is infinity minus infinity, right? So I changed it now. I went back to the positive infinity one. Okay. What is infinity minus infinity? Definitely not 0 because we just found it was 1/6. It's not 1 either. No, it's not infinity.
Indeterminate.
Indeterminate. That was also on our list. This is indeterminate. Remember, we wrote that list. Infinity minus infinity is we do not know. So in this example, the one we just did, we got 1/6, right? So it could be 0, it could be infinity, it could be minus infinity, it could be 10, it could be 100, it could be 1/6. Who knows, right? You need to figure it out. What's what?
What's 1/6?
Oh, that was the problem that we just did. We just did.
Infinity minus infinity.
That's the limit.
This is the limit. Yeah, we just found it, right? I erased it all. It was right here. If I hit undo like 50 million times, that would get one. It would show up there, but it's.
That's 1 over square root of 9 plus 3?
Yeah.
Okay.
Yeah, because it was 1 over the square root of 9 plus 3, right? Which is 1/6. Okay. Okay. So there was a reason for me to go back to this. Okay, now, so let me erase it. So I don't want to confuse anyone. Okay, now, minus infinity. So this is why you don't want to break the rule of plugging it in. Okay, so you plug it in here. What happens when you plug in infinity? Or no. Oh my goodness, not again. Minus infinity.
Infinity plus infinity.
Exactly. There we go. Okay. Now this is important because you have infinity minus negative infinity, right? Is that indeterminate? No. This is what is infinity plus infinity basically?
To infinity and beyond.
To infinity and beyond. That's right. That's like if Buzz Lightyear came in here. That's infinity. You don't even have to do any work whatsoever because it's not indeterminate. It's infinity plus more infinity. That's like supercharged infinity. You know, it's like getting big even faster. Right? I mean, that's like if you did, like if I wrote down, so you would never question this, right? I mean, what's that? It's infinity, right? So x is going to infinity, and then plus more infinities. Well, that's just still infinity, right? So going towards infinity. So that's the same thing that's going on here. The problem is that you get stuck into jumping into doing work, and if you start doing the work for this one, like you do multiply by the conjugate, do all that stuff, what'll end up happening, do you guys want to see what happens?
Yes.
Okay, I'm going to show you guys. Okay, take a look at this. Take a look at this. Confusion. Well, what happens is confusion. You can still make it out the other end of the problem by doing the work, but typically you get confused and you stop because you figure you did something wrong, I guess. It's kind of what most people do. But if you kind of go through the motions here, and so you multiply, right, by the conjugate, so now you're at limit as x goes to minus infinity. What did we end up with? We had x. What did we have? Square root of? Okay. All right. And then you divide by x, right? Okay. Let's see here. All right. So now we have the limit as x goes to minus infinity. 1 over. Okay, this is 1, right? This is 3. But then how do I get the square root of x squared business in there? Since x is going to minus infinity, okay, so this is going to be minus, right? Okay, all right. So let's say you did not forget to do that, which is pretty common to forget, but let's just say you did not forget it. So what do you end up with? Minus square root of 9 plus 3, like that, right? Okay, this is the problem. Are you guys ready for the problem? What is this? 1 over. Okay. Very important. What does this mean? It's not undefined. Constant over 0. Does not mean it's going to positive infinity.
Vertical asymptote.
Yes. Positive or negative infinity, right? At this point, so you know it's positive infinity just because we did it without going through all these steps. That's the only reason why you know. But at this point, when you get this, this tells you that it's infinity or minus infinity. Okay. But now, can you tell from looking at this whether it's positive or negative infinity? No, you can't. You have to go back here. And then it involves some strong trickery. Not trickery. Let's see. What would I call this? No, just maybe some good observational skills. So this is the denominator. That's the numerator right there, right? So do you guys agree? So this is going to be 9 plus 1 over x, like that, right? 9 plus 1 over x. Is it okay if I simplify it to that? Yes? All right. So what you need to do, so it's like, this is kind of like you already dug yourself into a really big hole. You could have avoided it by realizing from the very beginning that you should not be doing any of these things, right? But you're already in the hole, and then how do you dig yourself out of it? Well, okay, so then you go, okay, so x is going to minus infinity, right? Okay, so that means that this right here is that, so 1 over x is approaching 0, yes? Okay, that means this inside stuff right here, that is approaching what number? So 9, let me write it down just to make the point. 9 plus 1 over x is approaching 9, right? Okay, but the key thing here is it approaching 9 from numbers that are less than 9 or greater than 9? That's the important thing because that's going to tell you what the sign is overall. So which one is it? Okay, so can I do that, for example? To say, okay, well, 9 plus 1 over x, so that's approaching 9 from numbers that are, so like, are you guys saying that this is going to look like 9.1, 9.01, 9.0001, that kind of thing? Is that true or false?
Wouldn't it be less than?
Well, it's got to be one of the two. Which one is it?
Well, if it's negative infinity, wouldn't it be
Should be greater.
like less than? So we'd be approaching from the left.
It would, right?
Yeah.
So, did you guys catch that? Okay, so let's make sure everybody's on the same page. X is approaching negative infinity, right? Which means that this 1 over x, so we already know it's going to 0, but it's a negative number, right? Yes? 1 over x is negative. Do you guys agree with that? So if you add a negative number to 9, well, it's going to be less than 9, right? Okay, all right. Now, I want to point out that we are not doing this because, we're doing this because we made a mistake, right? What was our mistake? Not plugging it in from the beginning, right? If we would have we did, but only because I pointed it out. Okay, anyways, all right, we're going to make it. Okay, so this is approaching 9 from numbers that are smaller than 9, yes? You get the square root of that. You get that this is approaching, so it's approaching 3, right? Again, from numbers that are smaller than 3, right? Okay, so if this right here is less than 3 and you add 3, what's the sign going to be?
Positive.
It's going to be positive. Yep. And that's the key thing, is that you already know it's going to infinity or minus infinity. Since the numerator is positive and the denominator is positive, then that means it's going to go to positive infinity. But look at all these shenanigans we had to go through to figure that out when we could have just figured it out from the very beginning, right? Does that make sense? Yes.
Why the negative beside the radical just multiply by the radical, not the 3x? It shouldn't be negative 3x.
Because, well, it depends on how you're looking at it, but if you look at it the way that we just did it, we have been doing it here. So you have this x here, right? So you multiply top and bottom of this fraction right here basically by -1 is what you're doing, right? So it's like you're multiplying by 1. If you multiply this one by -1, well, then now everything is changing. I mean, you could multiply top and bottom, I guess. But then
If I
that's fine.
do that, I got -1/6.
Right, which is not true. Which is not correct. Yeah. Any other questions?
So
Yes.
to clarify, anytime you have 1 divided by 0, any number constant divided by 0, it's either going to be infinity or negative infinity.
That is exactly correct. Yes.
Universally. Okay.
Yeah. Yes.
And then so even when we are using the limits to infinity, we should still kind of plug in or plug it in.
Yeah, you
Because-
in quotes plug it in.
Okay.
Yeah. Yeah, you do want to do that for sure.
So if right off the bat you get a constant over 0, you
Well, here actually right off the bat really it was, remember it was infinity minus negative infinity, which is infinity. So right off the bat you forego all that other stuff and the limit is infinity and you're done.
But with a different function, couldn't you get a constant over 0?
Yeah, so if you plug in infinity, let's say, and then you get a constant over 0, then that means it's going to infinity.
And you
Or
don't have to
negative
do
2.
anything else to it?
Well, no, yeah, you have to investigate.
Okay.
Yeah, which one of the two it is. By doing shenanigans like this. Although this is worse than most. But
Would that be considered showing your work then?
this right here is probably not a good example of. This is like a very bad example. Bad example. See, I did this just to show you. Bad example of what work looks like. Okay. You guys want to take a little break or just keep going?
Right?
We could do that. You guys want to do that? We're well past the halfway point, so might as well. All right, I'm going to give you guys another one to try. You guys ready?
No.
What is it?
No.
All right, how about... this looks like a good one. The limit as x goes to infinity of e to the 3x and e to the 3x plus e to the minus 3x. All right, so should we... All right, so we said we can factor. All right, so one of the things... let's see. So you can factor anything you want. So one of the problems with doing this is that there are a lot of different possibilities. You can factor out an e to the x, or an e to the 2x, or e to the 3x, or a minus 3x. You know? Who knows? What should we factor? What should we do? Okay, so this happens a lot in calculus. It happens more the further you go. So this gets worse. So right now we have a pretty good set of techniques to do stuff. It's like, oh, when this happens, when the limit is this kind, do this technique. When the limit is this other kind, do this other technique. But then as you go further, the unknowns start getting, number of unknowns start increasing, I guess. I don't know. Okay, anyways, you just have to learn to get comfortable with not knowing what to do. Okay, so what can we do? Well, why don't we try factoring e to the 3x? Okay, now a very important thing, that if you try something, you have to make sure not to make an algebra mistake. Okay, this is crucial. All right, so if I factor out an e to the 3x, what would I have? Well, here I have a 1 minus, this is usually a problem, e to the negative 6x, right? Because what happens when you multiply e to the 3x times e to the minus 6x? What do you do with the exponents? You add them, right? So 3x plus negative 6x equals to minus 3x. Okay. Oh my gosh. All right. Now, well, let's do the same thing on the bottom. So it's basically the same thing, right? Okay. So now
I factored out a negative e to the negative 3x. Is
that may
get you there, or is that?
That's fine. It may be that we find out that this actually doesn't work, and then maybe e to the minus 3x does work, or the other way around. Or maybe both work. Did you get a number at the end?
No, I didn't finish it.
Oh, okay. But you didn't get stuck. You just haven't finished it.
No, I'm stuck.
Oh, you're stuck. Okay. Okay. Well, let's try it, and then we can go back and take a look at factoring out a minus 3x, e to the minus 3x, and see what we get. Okay, so right here you can see that these guys are going to cancel, right? Okay, now, what is that equal to? This is the limit as x goes to infinity of 1 minus, why don't I do this? Instead of having the negative exponent, let me write it as 1 over e to the 6x, like that. And then over 1 plus e, oh no, 1 over e to the 6x. Is that correct? Yes. It is, right? Okay. All right, so now we talked about this a little while ago. What's this limit? As x goes to positive infinity. Make sure you're careful with the sign. So as x goes to positive infinity, what happens with e to the 6x? That's going to infinity, right? So then what about 1 over e to the 6x? That's going to 0, right? And then what about 1 over e to the 6x again? That's also going to 0, right? So what's the limit? 1. Does that make sense?
If you plug in
Sort of.
infinity, what you can get is infinity over infinity.
If you plug in infinity where? Oh, in the beginning.
Uh,
Yeah, I skipped that step, didn't I? I told you guys never to do that, but I did it anyways. But yeah, you get infinity over infinity, right? Because you get infinity, basically you get infinity minus 0 over infinity plus 0, right? Which is indeterminate. It's infinity over infinity. Okay. So hopefully you guys did that. Because I told you guys not to skip that step.
Couldn't you just done that on the last step you did there, where you moved the even 6x down? Couldn't you just have done
That these are 0? Yeah.
negative 6x, it could be 0 too, right?
Yeah. Yeah, I mean, it was just a matter of, I think it's more clear if you're looking at it when the exponent is positive. Just makes it a little bit easier to tell. But yeah, saying this, that e to the minus 6x is approaching 0, that's fine. Okay, so why don't we try doing, what happens if you factor out e to the minus 3x? Let's see here. So just for fun, if I change this to factoring out e to the minus 3x, top and bottom, what would change? E to the positive 6x, right? Minus 1. E to the positive 6x plus 1, right? And these still cancel. But notice this is not helpful, right? Because what happens is you end up, where's e to the 6x going? That's going to infinity, right? This is going to infinity. Well, infinity minus 1, that's still infinity, right? Infinity plus 1. So this is infinity over infinity. What does that tell you? More work. So that's why I said, and so it was really just a fluke. I didn't know which one was going to work. I just did. I don't know. You guys suggested it, I think, and so then we just went with it. So here, if we would have started with factoring out e to the minus 3x, then we go nowhere. And
also, we can divide all of it by e to the 3x.
yeah, so it is still salvageable. For example, here, if I take this, I mean, it's not all lost. Just for fun, why don't we do that? This. If I take this and I divide everything by e to the 6x, let's say. Now that works, right? So it's not like you're totally lost. It just means, well, there's more work to do, right? So here, what happens? Wowzers. Okay. Here, this is 1, right? Minus, where does that go as x goes to infinity?
0.
This goes to 0. This is 1 again, and then 1 over e to the 6x, that goes to 0. So you end up with 1 again, right? So you can still make it, but, you know. Any other questions with that one, or is that okay? Okay. All right. What do you guys think about this one? That's not too bad. We can do that. Okay. What do we do?
Plug it in.
Plug it in. That's right. All right. So we plug it in. So notice this is a composition of functions, right? A function inside of another function. So 2 over x squared. As x goes to infinity, where does 2 over x squared go? Okay. And then what's ln of 0? It's not defined, right? Okay, but what we can do is we can do your favorite, we can do a substitution, right? Okay, all right. You guys ready? Pick a letter for the substitution. C. No, we can't pick C.
Q.
C is for constants. Q.
Z.
F.
A, B, C, D, F, G.
T.
Yeah.
T.
So normally, just so you know, So normally letters at the beginning of the alphabet, almost always, they're constants. They represent constants. And then letters at the end of the alphabet represent variables. Typically. Not always. So, Z,
Omega.
Y, Z. You can use Greek letters. Okay. All right. I was just against C. That was all. But, okay. All right. Let's change it to Y. You guys like Y. Okay. All right. So, okay, question. So, since 2 over x squared approaches 0, is this the same as writing the limit as y goes to 0 of ln of y? Yes, no, maybe, or almost?
Yes.
Yes.
Maybe is correct, but more correct is
Yes.
almost. No, almost. Almost. What's the problem with ln of y at 0? What's the problem with finding the limit of ln of the natural log function? Just think of the natural log function. What's the problem with it at 0? Well, it doesn't exist at 0, but what about if you approach it from the right or the left? You can't, exactly. You cannot approach it from the left, right? So it matters what direction you approach it to figure out what's going on, right? So in other words, so here, my point is this. If you're finding the limit as y approaches 0 from the right of ln of y, what is this? Negative infinity. But if you do the limit as y approaches 0 from the left, this does not exist, right? Okay. All right. So my question is does this have to be double-sided or should it be one-sided?
One-sided.
It should be one-sided, exactly. Okay. Now, y. What's the deal here? 2 over x squared. As x goes to infinity, this is going to be approaching 0 from the positive direction, right? Because all the numbers are positive, right? 2 over x squared is positive as x goes to positive infinity, right? So this limit, the limit as x goes to infinity of ln of 2 over x squared, this is actually equal to the limit as y approaches 0, but from the positive direction. Does that make sense? Which is then equal to minus infinity. Because it's this one. Does that make sense? What about the other side? What is the limit as x goes to minus infinity of ln of 2 over x squared? What is that?
0.
It's not 0.
It's the same thing.
Does not
That's what you
exist.
want.
So you have the same kind of deal, right? 2 over x squared is going towards 0, but is it approaching 0 from the positive or the negative direction?
Positive.
It's the positive again, right?
It's negative squared.
It's good.
Right. See how even though x is going to negative infinity, x is being squared. So this is always going to be positive no matter what, right? Because x is being squared even though x is going towards negative infinity. So this is minus infinity again. Yeah? It's a lot of details, right? A lot of little details that we need to pay attention to. But good times, right? I hope. Do you guys have any questions? Last minute questions? No? Okay. All right. Have a great weekend. I'll put up the homework today.